Hello, Assalamu alaikum. My name is Usman Kibaya, and today I will be presenting to you my project on an AI trained model to recognize hand gestures or sign language. The language that we have trained it on is the American Sign Language. Let's get on with the introduction. Okay, our project was to develop a real-time gesture recognition system, a real-time sign language recognition system in which the person does hand signs in front of a camera, and the model detects those images, studies them, and compares them with its data set, and then gives the word that has been shown in the camera. The key components are as follows, and the significance of this project was to enhance communication between the deaf community and the normal people. Okay, moving on. The methodology involves the following steps. First, we did the data collection. Then we pre-processed that data in various ways, such as we moved images that were too blur or unusable, or we rotated images, and as such then we developed a model and trained that model on that data, and then we tested the model for checking whether it was able to recognize those signs. Our data collection was done through OpenCV, and we downloaded data from Kaggle. We downloaded a diverse data set, and then for pre-processing of the data, we augmented it, we rotated the images, the brightness of the images was different and everything, and we were able to pre-process the data in a very good way. These are the layers of the model that was used. We used the CNN model with 3 convo layers, 2 max pooling, then dense layer, and output layers. Furthermore, the training process. In the training process, the parameters were as follows. There was a stochastic gradient descent, loss function, epochs were a total of 100 epochs. We ran a total of 100 epochs and a batch size of 32, and we were able to achieve a 96% accuracy. Yes, the real-time gesture recognition, the steps were webcam integration. We used a webcam in order to get the hand signs. Then we processed the live frames and used the model to predict the data, the hand sign. Furthermore, the results that we were achieved were over 96% accuracy. The model was very robust and was able to get hand signs from different locations and in different light zones. The model was trained on 26 the English alphabets, all of the 26 alphabets in sign language. And for discussion, the strengths of the model was there is high accuracy and real-time function. The challenges we faced was if the background is too dark, or if it's not giving very good, there is not very good contrast, not enough lighting, it was still able to pick up the hand signs and give us the result, and it was very heavy on the computer processor, the model itself. And the future enhancements is to bring that model from a computer device to a mobile phone, so that we can use a stronger camera that is generally available in mobile phones. Furthermore, we used the automated ASL recognition system. It was an automated recognition system that was trained mainly on the American Sign Language. For now, we only can train it on the American Sign Language, and its applications involve being an accessible tool that any deaf person has access to it. They can use it live on any platform, and it will help them communicate, since the model did not just print those letters, it also spoke them out loud. Once the dataset has been improved enough so that it can contain almost all of the sign language vocabulary, it would be able for a deaf person to be able to give a speech somewhere, a live speech anywhere, and the people that are not deaf would be able to understand them right away, since it didn't just convert those signs to text but also spoke them out loud. And we also intend to integrate different languages such as the Indian Indian Sign Language into the model, which is generally used in Pakistan and India, and the French as a sign language too, and many various other different versions of the sign language. Furthermore, these are the future directions. As I said before, it was to expand the vocabulary, adding other sign languages, and that the model should be available on the internet to anyone. All customers would be able to use it, and it should be more robust in real world conditions and less heavy on the processor itself. Furthermore, our acknowledgements are to the packages OpenCV, TensorFlow, and Keras, which were used into building this model. Also, an acknowledgement to my team member Abdullah Awan 2022 CS989. He helped me in this project. He was my partner in building this project, and the data sources that we got from Kaggle and Hugging Face. So, if you have any questions, feel free to ask, and thank you for your attention.